want cup of tea or anything?
Mm-hmm. Hello, and welcome to Coding with Gerph again, with exciting new titles that we're trying out just to see how they work and whether they're any good or not. All created by our friend Dave Thomas, so thank you very much to him. Okay, so where were we last week? Hello, Alan. Last week we were at the point of, let me just get to that. Yes, we just built, tried to build the module as 32-bit, 64-bit rather, but had problems with the linkage, which was down to the build environment. It was a problem with the relocation information that inserting the relocation information perturbed the relocation information, which meant that it never linked things properly. So I've now changed that, and in theory we should have some linkage that works. So I'm going to go and do a build of that. I'll do a clean first. We'll see how see that it actually builds everything. I've cleaned things. Now let's give it a whirl. Oh, hang on, no, clean, got to tell which file to clean, haven't we? File, make file lib. Sorry, there we go, that's cleaned that one. And then we need to clean the module as well. There we go. Clean the module, done. All right. So, all being well, we should have something that is able to be used here. Let's give it a whirl. So first we need to build the library. So build the library as an export, and this should be reasonably quick. And yeah, it's going to build it twice, one for modules and one for applications, even though actually they're the same thing at the moment. Right, that's now done. So we can go and do the build of the module. Let's build that. Fingers crossed. Dum 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 dum. Yeah, boring, boring, boring. We've got one warning, a few more warnings there. Yeah, that's a warning because of. I thought I'd fixed that. That's an error in CMunge. Just give me a second. Let's go and delete the mod head. And then delete veneer.o, o/veneer, sorry, o64 slash. Yeah, get rid of all of them. And then rebuild it. Let's see if that warning's gone away. If it hasn't, then I probably haven't. Yeah, I probably haven't exported the recent version of CMunge, which is not a big deal because I don't think we've got anything that's important into it. So let's run it. dev 64 command GOS. So this will drop us into a RISC OS 64 command prompt. Thank you very much. RM64, yeah, rmload rm64.debugger. That seems to have loaded. Help debugger. Yeah, it hasn't crashed yet, which is good. So let's have a see what we can do with dumping the file. Now the file we were dumping was it debugger? Ah, yes, we used to run it, didn't we? We used to run the debugger program, which of course won't work in the 64-bit RISC OS. So instead, we're going to only be able to dump it. So I can do DumpI. I can do DumpI hello world, actually. It'll be better, won't it? Dump that. All right. That looks like instructions, and it looks like they're doing the right thing. Address number 24 is hello world. Address number 30 here is the end of the hello world message, and it checks whether the two are the same, and if they're not, it goes and calls this generate error to say it returned the wrong values. This is one of my tests from RISC OS Pyromaniac that just checks that OSWrite0 actually does what we expect it to do. So that is a module that is working. So more usefully, we've got other plans in there. So help debugger. Debugger? That's not right. Help debugger. So init store. So that's interesting because that will init the application space to be an undefined instruction, but that's an undefined instruction for 32-bit, not an undefined instruction for 64-bit. So we're going to have to define a new one. So let's try and find an undefined instruction, shall we? arc64 undefined instruction. Is there actually? I think yes. There's an there's actually a profile for not profile, a definition of undefined instruction. So this particular binding is intended to always go and call the undefined instruction trap, and you can pass in a 16-bit value. So it's actually just another way of entering the operating system, if you like, but you can just force it. So with that information, yes, of course. So I just realised this. Right, in ARM32, we've got these instructions like this, and E at the beginning is the what's it called? The always encoding of the condition code. So if I just dump 4 bytes on there, you can see that this actually comes out as this is actually coming out as an undefined instruction in 32-bit ARM as well, in this case. But this is the E encoding is the always, and then 7FFF is undefined instruction binding immediate number FFFF. So we can do the same thing but for 64-bit. So let's do that. And this immediate value, we can just make it anything, but we might as well make it the same immediate value just for consistency. Right, where is this then? So this will be not in here, it will be in the veneer code. Let's have a look. So we're looking for init store. There we go. I quite handily defined that way. So if we are in RISC OS 64, otherwise 32-bit, arc 32 value, and then oops, not that much. There we go. And this is the same instruction, but arc64. Sorry, no, that's wrong. I've got the binding wrong there because that's 16 bits it's meant to be. And we might as well include the reference here to say what this binding is. There we go. So now when we build it for 64-bit, we get a different undefined instruction, which would be quite cool. Very, very slightly different, but also kind of useful. Right, what else are we going to be doing here? So I was examining the other functions, weren't we? So one of the things that I've done here is we've got this so break clear, debugger does not support breakpoints in RISC OS 64. at the current time, I'm not going to implement breakpoints just because I haven't actually defined how the prefetch abort handler and all of that part works. So that needs a bit more thought in the operating system and needs some sort of thought from other people as well, potentially. But right now, I just haven't done that. However, we do also have ShowRegs here. It says that there's no dump present at the moment, which is fair enough. So let's go and cause it to abort. We can do that by telling it to run the code that we just initialized. One of the handy things about what appears to be the encodings that are used in ARC64 is almost all of the common undefined instructions are actually invalid. So you get undefined instruction here. So there we go, we've got undefined values, and as I've mentioned, this isn't decoded properly. But we have got some values here. So now if I go into ShowRegs, oh, ShowRegs didn't work, did it? That's interesting. Whoa. So what we can do there, Pyromaniac debug trace, and then run it. So we got a little way through it. Oh dear, oh dear. Yeah, that's broken. This is something that I've noticed with the current build of Pyromaniac, in that sometimes when things go wrong, it just cycles forever, and it's not clear why. We called strlen there on. Ooh, that's a big value. That's not right, is it? I think I know what this is. Yes, I think I know what this is. So, yeah, this went wrong, and then it blew up quite badly. It just sort of seemed to cycle forever. Not really sure why, because that backtrace is clearly garbage. And it couldn't go on forever. We don't have enough stack for that. So something's up there, but this has told us something. It's told us that we die inside the strlen, and I think that strlen, if we look back here, don't see we find the function that we're in. Kernel SWI platform features. Yes, this tried to return the platform features and tried to read the register block that we've got, which then failed. So with that in mind, let's go and have a look at the introspection here. So this is a bit that calls platform features. It calls get platform features there. And this is where we describe the exception dump. That's where I get the region for that. Read the report information. Okay, and then presumably this is the actual implementation here. ShowRegs calls, reads the different values. Now, I think what's going wrong here is that some of these pointers are not correct. So if I go back and look at my definition of the CPU architecture registers, we've got things here that are ints and longs, and I think that these have got it very confused as to what is there, because they should be 32 bits. So those are okay because they're 32-bit values, but these may not be. They shouldn't be, but anyway, let's just make them into uint 32s, so everything is going to be consistent. Uint 32. That's my own foolishness when I wrote this. I didn't use the new types to actually write them properly, and it's still possible I've got it wrong as well. Uint 32. There's many bit fields in this definition, so those can all stay as being just bit fields because they won't matter, but the other ones will. Here, uint 32t. oops, no, not two things. Terminator. Wouldn't that terminator be a? That should be a U. I'll define it as an int32 because that's what it had originally, and these are also int32s. Okay. All right. Let's see if that builds and runs a bit better. And whilst we're at it, temporarily, we'll just comment out the early return, so we still print it out even if there is a lack of dump on there. So let's give that a whirl. Build it. Oh, is that in the library? Is it in the module? It's in the module. That's good. Okay, and then we can go and run it. ShowRegs. Exception dump is empty, but then you didn't. Okay, that's odd. Go 8000. Right, there we go. ShowRegs. Ah! That was all it needed. So we've still got the process state coming out as this garbage thing because that's what's being returned from the operating system. Is that what's being returned from the operating system? Yeah, it looks like it because that's actually all defined in the table. There's no special case for decoding those flags, I don't think. Right, flag fields. Yeah, it doesn't look like I've got any special case for that. Right, yeah, right flag fields actually is a literal. We just write out what's in the table, so this shouldn't be a particularly difficult thing here. Okay, so yeah, and what we got there is we got the dump of the registers, the 64-bit registers, locations in memory, which it can know where we've got those located, and the different abort information, which is quite cool, really. Well, I'm quite pleased that that's actually working. So, for now, I'm happy with that. I mean, that's not obviously completely correct, but it's read it from the operating system and printed it out, which is what we wanted. So, yeah, let's go get that committed because that is an actual change. Oh, and I need to remove this change as well. That was in ShowRegs, this one here. Yeah, because that was just to prove that things were working. Oh yes, it also tries to print out some disassembly as well, if it can, which is quite cool. But that's because that's not particularly helpful the way it was doing it. Alright, let's go and commit that. Just check it's all right. Yeah. Alright, so this is fix for 64-bit architecture register header. So ShowRegs fix. Of the registered dump table of the current architecture. However, this was not. Hang on, there's somebody at the door. Oh. You got that? You need me to get that? Got it. Okay. All good. Right. However, this was not using the correct types So the 64-bit reads wrong values. ShowRegs then crash. Okay, and we can see the registers can state properly. Alrighty, that seems to be pretty good, doesn't it? Yeah, like that. Alright, so that's one good thing. Let's push that so it's up on the site as well. I didn't actually test that built 32-bit, did I? Probably should check that because yeah, still builds 32-bit as well, which is nice. Okay, so we now have 64-bit module. Was there anything else in the 64-bit module that we can actually see? Let's go and have a look. Help debugger. So, oh, hang on. Yeah, that isn't the same thing. Hang on. That's why it looked wrong. That's not working then. I didn't load the module. You have to load the code, otherwise it doesn't actually work. All right, let's try rmload 64.debugger. Let's actually try running the code. Okay, that was less good. So, bother. Yeah, I should have noticed that the output was looking not like what I was expecting it to, but it still looked kind of like what I was expecting it to. So why are we getting question marks in here? That's kind of interesting. And then we get a crash, which is also interesting. Here we look, we've actually got a decoded set of flags here. It knows it's in user mode 64-bit. So that's what it should have been doing. Well, that's quite nice. But all this is coming out with question marks. So, why do we get question marks? I don't know. Oh, I wonder if it's because we don't support... I don't support that long a bit width. That's why. So, in the register definitions, here we've got, we say where they live. We've already decoded where they live. Or we've got decoding here for where they live. But we also say how wide they are, and then we AND them off. But never actually implement it for 64-bit. So let us do that. 64, right, hex. Oh, I suppose we do hex 8 there, don't we? Yeah, oh, these are probably wrong as well. So let's do them properly. uint 16t. I feel very foolish for having not read the right values, looked at the right commands. That would have been very stupid. uint 32t, and then this one is uint 64t. And we'll only build this one when we're in, if not. Yeah, we'll only build it when we're in 64-bit. Assert. So, Dave suggested I should use assert on there. And yes, I probably should use assert on there, but asserts inside a module aren't generally a good idea. Yeah. For now, I'll leave it as this, but yes, that is a good point. I probably should do that. Actually, what does my assert handler do? I think my assert handler calls os exit. RISC OS simple binaries. Here. clib. What would it be in? I think it's just at the top here, isn't it? Yeah, assert.c. Writes out some information, does a backtrace, and then calls os generate error. And if os generate error fails, for any, or continues for any reason, we then call exit 0. Maybe we could detect whether we're in a module there. Yeah, we also try and restore the environment, which actually we definitely shouldn't do if we are, and we shouldn't finalize either. Ugh. In fact, all of that should be handled by the generate error call. So generate error should go into the environment handler should do the finalization and then the restore and decide how to handle it. Yeah, this is going to be a problem for another day, but yeah, the assert handler is not sufficient here. So I'm going back to where I was. I need to write out 64-bit register, which means write hex 8 is needed. And I don't think I have a write hex 8 in my IO code here. Huh. Well, this is very amusingly tacky, isn't it? Ooh, they're also not using. Let's use uint. This is largely just so that we actually get the things being passed through a little bit more efficiently. But uint 32t, and then finally for this one, this is going to be 8, and we're going to have a uint 64. Only build it if def it's got 64. Right. This one's going to be 8, 9. Yeah, that's why I've done it that way. That's fine. 11, 12, 13, 16. Let's give us a bigger buffer. Yes, I could just use printf. Why didn't I use printf? I don't know. I suspect I didn't use printf because it was a this was intended to be more efficient, because printf is pretty bad. 36, 40. I could also use a loop here, but no matter. Also, the compiler will do quite fun things to actually unroll loops if you give them, or make things into loops if it can spot that they can be. So there we are, there's write hex 8 written. Let's just copy that into the header. Dum. We build that. Is that part of the module, or is it part of the expected bracket? Or I haven't included studint. Yeah, I need to include it in here. Include studint.h, and also I didn't change these ones because these are all changed in the other file. Okay. Over here, build it. Oh, C file. So I wasn't. Why did the C file? Is the C file not including its own I/O? Ooh. So this is bad because I was not including our own io.h, so we wouldn't actually notice any inconsistencies. Implicit narrowing cast in ShowRegs, fair enough. I'm assuming that's just the values. Right, this time, load module RM3064. I'm going to actually remember to load the module before we start DOS. Now when I do ShowRegs, it'll actually give us the real information. That still looks wrong. Why does that? Oh. I only built the 32-bit module. Build 64 equals 1. Righty. io.c line 13. Oh, I bet I forgot to miss the semicolon when I copied it. I did. I missed the semicolon. There we go. Oh, I'm tired now. I was up till late again. Right. Dave suggested, I guess this is why we have fat binaries on macOS. Yeah, I've been trying to work out what I could do with that, whether we should have a way of having a 32-bit and 64-bit, because it's not just going to work in 64-bit, but it's got to be a file format that also is valid for 32-bit as well. And I think we can do it, but it's still a bit more painful. It definitely needs more thought, but it would be useful. Of course, if we had a container format, like let's say ELF, we could do this a lot more easily. But we don't load ELF files as part of the operating system at the current time. I'm still tempted by it though. No dump present. That's more like what I was expecting. Then we do init store, go 8000. And then we do ShowRegs. Ooh. All right. So here we've got a whole load of 0 registers being dumped, and then we crash because we can't. We print this out and we go data abort. So what I'm going to try and do here is I'll just start again. And init store. Go 8000s, crashes. Then MemoryI debug trace. And then we'll do our ShowRegs. Whee! Of course, it'll go a bit more slowly if it's having to decode all the registers. So decode all the instructions that are being executed, but it should still crash. Maybe I should have written this to a file instead of outputting it to the screen. Would have been faster then. Dum dum dum. I'm regretting my choices now. One of the reasons for making the code slightly more efficient by using that those write routines, other than obviously going through printf, is that when you do a trace like this, it's actually easier to see what's going on because the code is so much more easy to read. I mean, that's not a great reason for micro optimizing like that, but okay, this is tedious. Let's kill it. Jobs. I've got 2 of them running. Let's kill present2 as well. Foreground. There we go, they're dead now. And then we'll run the same thing again, but we'll output the output to trace file. Which should be a little bit faster. Init store. Go 8000. ShowRegs. See, that's way faster. Now I can close down and we can go and have a look at trace file. Which is empty because I didn't actually turn on the debugging. Let's try again. As I say, I was a little tired last night. That was my own fault, going to bed late. Init store. Go 8000. MemoryI debug trace. Okay, now do ShowRegs. It'll run a little bit more slowly. Yeah, this seems a little bit more slowly. Oh wow, this is going slow, isn't it? Ooh. I didn't expect it to go quite this slow. That's really interesting. Maybe I shouldn't have gone straight for the trace. Maybe I should have gone for trace block, which would have given us slightly less information, but it would have at least... there we go, got something out. Oh, this is tedious. Right, whilst you're doing that, let's have a look at what we actually do in the ShowRegs code. So we printed out the P state, and then we got stuck, didn't we? So what do we do? This was oh, look, there's another bit here that tries to print out registers. Let's just fix that one as well. 64, 8. If def 64. That's one thing fixed. So it wasn't the PSR in there. Ooh, fault address, that's possibly wrong as well. That's interesting, because that needs to be a wider value if we're in 64-bit, but you don't get that information from the exception table. Maybe we should have a call that reads the address space size. Yeah, that would be really useful. Or it should be in the architecture registers information. Could probably add it to the architecture registers information, actually. Would be useful in there. Right, for now, however, let's just make that one if def RISC OS 64. Oh, give me a second, I'm going to write that down because I'm going to go and forget. I mean, I suppose if you know the system, you know what the address space size is, but of course this is a 64-bit system that actually only has an address space that is 32-bit. The rest of it doesn't exist, but you could have a fault in that in 64-bit space, and you could jump to something that's higher and doesn't exist. Master fault 64-bit, add interface and size of address space. Okay, so that's really a OS platform features type call. It would be. Right, let's just quickly finish what I was writing there. Alrighty. Okay, and all of this is doing the usual sorts of things for the dumps. All right, so yeah, not really sure what's going on there. I think it's in, what's that error? Unmatched brace. That means that I've, oh, else. Yeah, that's one. Else, diff. And my warning there has gone away. Gone away, thank you. Right, it's still dumping things. I think it's in right field flags, is where it's got to, I believe. Like flag field, sorry, which is up here. So this does a whole load of things. It does reads lengths of types of data and then flag values, writes things out to pad them, and the named values, flags, let's see, any other type of definition. And then we were, oh, is it possible that I've overrun a buffer or something? It's quite possible. What do we write into? We don't write into a buffer. Oh, wrote is actually the number of fields we wrote. Oh no, it's not exactly whether we wrote anything at all. Okay, fair enough. It's still doing the final stage here, which is almost certainly printing out stack pointer and PC, and then processor state, which is when it went and crashed. Maybe I should have made it not print anything if it's in the other areas. That would have been a thought, wouldn't it? Could just skip the writes, and then it would have jumped through it a lot. Well, even still, they're not very inefficient. Anyway, I'm just waiting for it to complete now. Wow, this is tedious. If I was thinking it was in that function, what I could have done is set a trap so that when it hit that, it would go and turn the tracing on. That might have been useful. And then I wouldn't have to go through all of this stuff here. That might have helped. But not a big deal. Can cope with that. Come on. Unless it's got stuck, of course. It's always possible. No, it can't have got stuck. Because it definitely crashed before. This is the trace here. That's a long trace. Does it look like it's just repeating itself? 9-4, A4, E4, E4, B4. That kind of looks like it's just rolling on and on and on and on. Yeah, I think it's just... Yeah, that address is just incrementing. So we've got stuck looking at the table. I can see this just keeps going on and on and on. So let's scroll back. Oh, there we go, we hit something. In fact, let's see what the last function call was. Function colon. Actually, it's right calling printf. Okay, well that's an interesting way of doing things. Maybe I shouldn't have done that. You know what the best thing is to do is go jump into this bit here and then search backwards for the last function. Right, os right C. Helpful. Let's just see spin, that's printf. Printf, there be printf, printf. Right C. Strlen. What were we strlening? Whatever's at that address, which I don't know. Compare with 40. Compare with 5A and 60. I think those are the different types of register. Let's do this a different way, shall we? Perhaps a function in choice.text. Ah, okay. Yeah, that doesn't help us very much either. I do think it's just got to the end of the table and it's rolled on, though. I think that's what we've done here. So this is where we start going forever. So what do we do here? We've returned back from routine, so we come back and return here. We've got another return here. Set things to 1, branch to a place. Set to 1, branch to a place. Loader value, is it 1? If it's not, go to here. And then we just keep cycling. No, not that one. Compare 120. Yeah. So I'd really like to be able to have breakpoints where I can actually mark where things are and then say, whoa, where are we? What are we actually doing? But I haven't got debugger data extracted from the ELF file to be able to do this. Yeah, it's something I'm going to have to look at. But okay, so this table here goes down here. When does it terminate? When do we terminate table? Whilst we have a arcreg terminator is not arcreg list terminator. I'm wondering if the terminator is not what I'm thinking it is. Because if that's the case, what is the terminator? Where am I looking? CPU arcreg. Terminator is a long unsigned. And we read the terminator there as that. And that is a int 64. It should be a uint 32. That would do it, because we'd be reading the wrong thing. I'm gonna all of the others have got the right lengths. Because that looks like it's got a got what is the terminator there. Except this says, isn't that load signed byte? Add 10 to it. Yeah. Well, okay, foreground that, stop it. Kill %2. Oh, %1. Okay. Yeah, fine. There's all our returns. There's the. But I'm not sure what that. I thought that was load signed byte. And if it is load signed byte, then fair enough. That was what it was doing. But I didn't think the terminator was defined as a signed byte. It's defined as a uint there, uint 32, and that's defined as that. If it's looking for 1, let's try it again. Let's get. I've made a small change. I'm going to build it. This is definitely not the best way of debugging this. I could, of course, run it in command line mode, in user mode, and just build it in manually, but that's fine. I'm not going to go and run the trace this time. I'll keep the trace that we've currently got and just see what happens. Init store, go 8000, ShowRegs. Oh, that fixed it. Well, that's good. It was just that. Okay. Well, that's good then anyway. Fair enough. Well, one of the interesting things about this is the P state that's been stored here is incorrect, and the PSR here that's being stored, this one here, is actually correct, but not for the right reasons. It's correct because it's written a PSR to there, but it's written a 32-bit PSR, as in an actual ARC32 form of the PSR, because internally in Pyromaniac we just convert all of the PSR values into 32-bit rather than using the 64-bit value. And the reason for that is because then I can go, oh, switch to SVC mode, and it switches to exception level 1. But it thinks it's just switching to SVC mode. Changing all of the code inside Pyromaniac to say change to SVC mode or change to IRQ mode or back to user mode would be a bit more complicated, so I haven't done that. I've basically botched that part of it inside Pyromaniac. So it looks like a 32-bit environment that's sort of actually 64-bit. For the most part, it doesn't actually matter because it's internal to Pyromaniac, not exposed to the rest of the system. But here is one of those places where it does bleed into the rest of the system. Right. Git log diff. Sorry, I want to see what I just changed. Okay, so this is all part of the last change. So if we just show the last change, that's all part of the same thing. So I'm going to go and commit all of these changes and end them onto the previous one. So I'll just make that last change include these changes, and I'll force push that. Because I know I'm the only person working on this, force pushing is fine. I shouldn't really do that. I should really be doing this on a branch anyway. And I was doing it on a branch when I first started this work. I started doing branches and then merging the branches in, but I've become more lazy in time, which is fine. If anybody else was working on this, then I would change my behavior and be a bit more conscientious about what they were doing. But anyway. Okay, so having messed around with that, we've now seen that DumpI works, MemoryI works. Breakpoints don't work because we've disabled them. They're not implemented in this version. And consequently, neither continue. Just check that doesn't work. Continue and debug. Yeah, none of that does anything. Memory works fine. Let's just confirm that. Yep, that seems to be working. Memory A. Enter a new value. E7 1 2 3 4 5 6. Wrote that. Escape. Memory I 8000 plus 8. Yep, that has updated the instruction, so that is correct. What else? Sorry, I've already forgotten the debugger things. MemoryI install registers, DumpI. Yeah, that's everything then. So all of those are now working, which is kind of cool. And that means that we can hopefully say 64-bit working fine. Yeah, 64-bit working fine. So, this one here, build the module, and we've checked that everything worked. Ensure that it runs in the CI build system. Now that means I need to get it to actually build in CI, which I haven't got yet because I haven't published the RISC OS CMunge for 64-bit. Or have I? I have, but of course we haven't got the rest of the build environment up there. For now, I'm gonna change that. Can I edit it, please? Oh no! Oh. Convert to issue and sub-issue. What's a sub-issue? I've done sub-issues in other systems, but I don't. Oh, I'll look into that later. Yeah, for now, let's edit this and. Oh, stop it. There we go. That didn't do the right thing. Is it underscores? Is it hyphens? I can never remember. No, let's try underscores, Sharifa. Nope, that's done that. How do you do strike through in tildes? Says see if that comes up. Yes, double tilde. Okay, thank you very much, Dave. You just beat me to looking that up. I mean, that kind of looks like it. Right, thank you very much. See, having people here helps. I can at least do things. Right, so this has now been built and tested on my machine. Works fine here. No CI set up for it yet. Right. And close issue. Right, with that done, hopefully that'll move to the done column. I want to create another one in here that says create CI for 64-bit build. Thank you very much. Yes, I want to create it here, please. There's a blank issue. The 64-bit version of the debugger needs to be able to be built in CI. That'll do. Don't care about much more than that. All right. So we still have a bunch of issues with this, and IFSR, DFSR is one of them. ARC64 disassembly is another. Adding the new Debugger plus SWIs. Comments on constant values, and that's really interesting. However, FPA instructions is probably more significant because we don't have that support right now. We have it in RISC OS Pyromaniac, but we don't have it here. So I'd have to add that. Now I've got two choices about how I do that. I could add the FPA instructions as into the table and then have a special extend the table so it can do those FPA instructions, or I could write an entirely separate interpreter for that. Neither of which are particularly filling me joy at the moment. So what I'm going to do is I'm going to think on that one and see what I want, how I want to do that. Because yeah, that would be useful. So other things we can do though, there's a suggestion here of using ADRA and ADRA-T and Instruct-T to try and differentiate the types of code. Could do that, but it doesn't give me very much. This, however, is more useful, showing IFSR and DFSR. So in ShowRegs, we report the PSR and fault from there. It would be nice if we could report the IFSR and DFSR when there is an exception. Maybe it means a new call to report this or falling back to reading it directly. Now, if I remember rightly, I'll go back to over here, we actually have this. So if we do pyrodev and just go into GOS normally, if I just do ShowRegs, so this is the Pyromaniac one. Oh, go init store, go 8000, go 8000, bang. ShowRegs, right. So here, no, we don't have the IFSR and DFSR. I thought I'd added it. That's kind of interesting. Okay. I'm not really sure there. Yeah, it would be nice to include though. Let me just have a look at the Pyromaniac code and have a see, because I thought I had done IFSR and DFSR. So let's do that. New terminal. Thank you very much. Projects row Pyromaniac, and then we want to have a look at RISC OS modules. PyMods for Debugger init. Is it init or is it init? Okay. So I want the command ShowRegs. Command ShowRegs. So we call the standard exception dump area printing. This is the locations output. This is the bit that does the disassembly before the program counter. And here we are. This is where we have the IFSR and DFSR. So we do have those in there. Oh, we do print them out if they happen to look interesting. I wonder why they didn't look interesting for the other one. I'm assuming they end up being 0. No, it couldn't have ended up being 0. What did it print out? It just printed out fault at 8000. Oh! Yeah, it would have gone, the DFSR, the data fault was at 8000. But then it should have. There's nothing else there. I wonder why. I'm going to look at it a different way. So let's just do it a different way. Common and then GOS. This gets me a basic. I can drop into basic here. Because then we can do something like print the address and 8000. That. Wow, I don't know how to write basic code anymore. But then I can do the same for a bigger number, and it goes abort on data transfer. And then there we go. Data fault address register and fault status register was a read. It was an MMU access at for the second level. It basically decoded part of the MMU table and decided that the memory wasn't there. Obviously faked inside Pyromaniac, but that's what it was doing. So we can replicate that code if we wanted, and I think it's kind of useful. So this code here is not especially difficult, except I have to obviously read the IFR and DFSR message. Just checking that I'm okay with me coughing. Yeah, I'm good. I'm just I could probably do with a drink actually. Taylor, can I get a drink, please? This is very nice. I can ask for a drink and might be able to get one. Otherwise, I'll go and pop down in a second. Right. If I am going to copy this code, let us try it. So, yeah, we're going to try adding this in now, just for the heck of it. So, copy this code, and we want it in ShowRegs. Here's where we do all of the abort stuff. PSR. And this particular bit of decoding will only be relevant for the code we're doing in the what's it called? The 32-bit mode, because IFSR and DFSR will be handled differently. So here's the code we want. Since we've got this here that's printing out the last abort there, we can try and tag it onto the end of that code. I'm not sure this is going to be a particularly sensible thing to do, but let's give it a go. What's the worst that can happen? Yeah. So, if we're not in 64-bit, we'll just do it one way. Okay, we need a way of getting IFSR. So let's have a little bit of stuff here that does this. So IFSR, IDFSR. Fault info, we'll call it. Oh, yeah. Get fault info. What did we read? And populate into fault info. Okay, so that'll get us an IFSR and DFSR. I'm going to define this to be type def fault info struct. Wow, it's been a long time since I've written C code properly, isn't it? uint32 IFAR IFSR. Sorry, I think I've been talking about these and I haven't actually explained what they are. So, when there is a data fault, so you've got an access memory that doesn't exist, or memory that's got the wrong protection level, or you've written to memory that can't be written to, the data fault address register, the DFAR, is set to the address you were trying to access, and the data fault status register is set to the flag, a set of flags that say where along the processing it went wrong, because it could have failed because the memory isn't there, because the memory is protected. It could have failed because there was an address line bus problem, so something external signaling no, you can't do that. Or it could be a fault when it's doing the translation table lookup. So the translation table has layer 1, layer 2, level 1 and level 2, sorry, page tables, and those MMU levels are what was being talked about here. It gets to the second level. So first level is usually megabyte alignments. Megabyte? 4 megabytes. Can't remember. I think it's 4 megabytes. And then that gets broken down into 4K chunks, and they can be subdivided into 1K chunks, if I remember rightly, for tiny pages. Always tiny pages, 256 bytes. No, I think it's 1024 bytes. So that's what that's for. And we're basically able to extract that information by using a particular instruction, which I've forgotten, and I will find out. The IFAR and IFSR are exactly the same thing, but when an instruction fetch fails, so for example, if you try and jump to some code that doesn't exist, memory that doesn't exist, or you jump to some memory that is not existing at the current protection level, you're not able to read it even. And again, that can also be faulted externally, or at the different MMU levels. There's a lot of them, and I'll show those in a moment. This is the IFSR stuff. So we've called that with the fault info read. We've already printed out this stuff. We've done that. We've reported the fault address and those things there. So we're now on to this bit here, which is the IFSR and DFSR stuff. So we can do very similar code here. So fault info dot is not equal to 0, or fault info IFSR is not equal to 0, or fault address is not equal to 0. I don't know why we did that. That's interesting. I know why we did that. Yes, that's actually the value of last abort to fault address there. Is not equal to 0. And I think the reason we did that is because the address you could have been trying to access could be an address that doesn't exist, but you've accessed it from 0. Is that right? Yeah, not sure. Not going to worry. Oh yes, of course, they could both be 0, and the faulting address could be. Oh, I don't know. I'm going to strip that one. I'm just going to strip it because I can't remember how it's meant to work. So let's do this. Abort PC. Abort PC is last abort PSR, last abort PC. There we go. So last. Actually, if I'm going to reproduce this, let me reproduce it in exactly the same way. I'll stick with my original belief. Last abort, and we can see whether it works or not. Or fault info dot. So I've got a few bits here that are a little different in Python. Yeah, so we have to break these down into little sequences. So write this bit here all the way to the ampersand, then do a write hex 4 of fault info dot DFSR, and then write, oops, no, that up to there, and then write hex 4. Is it hex 4? Oh no, it's a string. Oh, because we've got a description. Oh, I've got to decode it. Fault info DFSR and then write closing bracket. Ooh, that's so much more tedious. I could have just used printf, but then that would be more involved and so on. So let's not now. Oh, I missed the bracket. Oh dear. Oh gosh. Right. Okay. Last abort PC. Last abort to abort PC. It was abort PC, wasn't it? No, it's just called PC. Semicolons to, thank you very much. This is a problem with jumping between languages. You end up very, very confused about which what syntax you should be using, or at least you look very stupid that it doesn't work. So this is actually almost identical code. So the IFSR, this is the IFSR description. Dave has similar problems switching between Swift and Flutter. I don't know what Flutter is. Swift's one of the Mac things, but Flutter? I think I've come across it, but... And what I'm actually going to do here is I'm going to go and just comment out these so I don't have to implement them initially, because I'm lazy. And then we'll last underscore abort on this. Default info. DFSR. Ooh, we've got 23 people watching, it says. This is quite surprising, actually. So this does the descriptions of regions, and yeah, I'm not going to do the region descriptions because I don't think we've described them in the upper section. So we won't do the description of the region, but we will print out what the address is. Apparently Flutter is a combo of iOS Android mobile framework. Its language is Dart, which is C derived. I've heard of Dart, I came across it recently. Learning all sorts of things here, aren't I? I should really try learning some other languages just for... so I know what is going on in the world, because I've been very, not very isolated. I mean, I know lots of languages, but it's more a case of having a better understanding of what's going on. And then just end that there. And I think the AR is going to be exact. Oh, hang on, no. Fault info. In fact, this entire code section is exactly the same. It's just with the IDs replaced with I's. Come on. IFSR, IFSR, and done. Okay, so I need a brace around that, and a brace over here as well. Oops. Yeah, so that looks like it would do the right thing. Oh, and I wanted to put this into a block itself. Like that. There we go. You've got DFSR again. On line 364. That's got DFSR. Was that meant to be AR? I think that's meant to be AR, isn't it? Yeah. Oh no, I see what you're saying. Yes. Oh, I see what you were saying. Sorry, I was moving code around too quickly. This one here, it's labeled wrongly. DFSR, IFSR, DFAR, IFAR. Yeah, there's a little bit of a lag on the chat, and I'm obviously editing away whilst we're talking, so me own fault there. Okay, so we've got that. So let's also void fault info read fault info t. So there's the definition of that. What was the other one I was needing? Oh, these ones here. So I'm not going to actually define them just yet, but I will give them void can't blooming type. Oh no, void, it's const char star. Oh no, they're going to actually write things out, aren't they? right description it should be, because I'm not returning it. If I return it, I have to get a buffer, and I probably don't want to do that, so I'm just going to write descriptions. Although returning a buffer would mean I could test it in the future as well. Yeah, well, no matter. Okay, that looks all right. So now we'll create a new header file called fault info. Header file called that. There we are. Fault info returns information about the most recent faults. IFSR. Date today, 13th July, go to 5. Right. Read the IFSR. Read the fault information into the fault structure. And returns none. Fault info, DFSR. Right. Right to view the value. And all that exactly the same, but for IFSR. Okay, and we're not going to implement those just yet. We're just going to implement this one. Save, copy, new file, fault info. Actually, I could have implemented them, couldn't I? I could implement them as right one, not implemented. That'd be much more useful. I could even spell it right as well. This is where I realised that I can't actually implement it in C because it has some certain instructions. Well, bother. So, if 0. Yeah, so we'll implement that one in assembler. So let's just create a IFSR DFSR file. Yeah, there we go. And I want a definition up here that looks exactly the same. code read only. Yeah, writing assembler is fun. I have to remember how to use this thing. However, I think in Pyromaniac I've already got some code that does it. So let's have a quick look in testcode/s. Not less, I didn't mean less. I meant OS. Actually, probably easiest to do grep for IFSR. Env prefetch. Okay. Less test code. Less. Hello.
Do you want a drink or you?
I would love a drink.
It's coming on a break soon.
Oh, it is coming up to break time, isn't it? Yeah, I'll do 10 minutes and then I'll have to come down and have a break and do a drink. Yeah.
Give me a cup and you want.
Oh, thank you very much. Ta.
I'll leave it downstairs for you.
Ta. Bum, bum, bum. Right. That's interesting. Yeah, didn't colour it with syntax colouring. Maybe I haven't implemented that. Anyway, let's look for the IFSR stuff. There we go. That's fetched the IFAR and the IFSR. Yum. And I guess we don't have a DFSR in that one. It's very similar. Right, okay. So oh, I need to have this works, don't I? Go back to the header. Fault info read. I'll put into R1, R2. Then we can do STM IA R0 R1, R2. And then you do the same for the DFSR. If I jump back here, I don't think, do we have any grep for DFSR code in there? Oh, not C/. We don't use the DFSR, but in ARM vectors we have code for this. So if I remember where that is, it's in ARM vectors. Oh, I'm in the wrong place. ARM exceptions. Is it in the ARM exceptions section? Could be. There we go. There's the instructions. So IFSR accessors are those ones, and the DFSR accessors, read ones, are these ones. So yeah, the difference is The difference is in the final argument. What I'll do is just copy the chunk of code. There we go. Apparently those don't need numbers on them. And then we can do that as, oh, and they want to go into R1 and R2 as well. DFAR and DFSR. Yum. It's quite exciting, isn't it? No, not really. Okay, so that's that implemented. So we need to see if this all actually wires together, shall we? Fault info, that's the header file. Fault info here. That's implemented in assembler. I don't need an endif on the end of it. Good. And actually, because I'm calling these, I can actually go back to my ShowRegs code and call them. Because, well, why not? Oops, missed. There we are. Oh, I've forgotten to close my ifdef there. So I need to do it here. And then we need to update the make file for the module to build both of those things. So makefile module, ifdef build 60, if not 64-bit, do that. And o.ifsr DFSR, and o. Fault info. Brain had just gone blank then. Right, let's see how badly I've written that. RISC OS ammo. Oh dear. And I'm losing the ability to type as well. Oh, I'm in the wrong environment, that's why. Drop out of there. That one, but not 64-bit. Has no members. Oh, I've forgotten to include studint. Yeah, that's going to fail it. And did I actually include... I don't think I even included that into ShowRegs, did I? So we go to ShowRegs. Yeah, I've used it, but I haven't actually declared it. I'm going to include. So include fault info. Only if we're not doing 64-bit things. Last abort has no last abort PC. Yeah, that's because I typoed that one. That's at 349. 349. There. Yep. And I think it said that I'd not. Yeah, I used the variables explicitly, so it should be just false. Info. Ooh, wrong place. Info.dfsr. IFSR. So likelihood of this working is obviously pretty low, as I've just written it and no idea whether it's going to work or not. But we did get a build, so that's cool. So common. We'll go straight into. Oh, we'll load the module. Otherwise, I'll get confused, like I did before. And we'll go straight into basic. Okay, come on. Thank you. ShowRegs. Let's see it go bang. Oh! Oh! That looks about right. I mean, apart from the fact that I've put out a new line on the end of it, I'm feeling pretty good about that. All right, so let's just fix that one right now, and we'll see what we can do. Where is it? Fault info, not in, it's just right, not writing. Right, there we are. So that should be pretty good. Right, we're off for a break right now, but just before we go, we've had somebody just come in and ask, what's an ARM disassembler? Which is a very fair question if you've just joined. So ARM obviously is the instruction set used by many devices these days. There are many different variants of the ARM processor, and the main ones that get used in mobile phones and the like these days are 64-bit variants. The ARM we're talking about here is the 32-bit variant, the older version, and we're trying to create a tool that will go and turn the executable code back into the mnemonics, these things that describe what the instructions actually are. That's what I'm trying to do here, and doing various parts of decoding what has gone wrong with parts of the system. All right, I hope that gives you enough information. Our new joiner, Shrekwi, I can't pronounce that. But yes, that's what we're on at the moment. I'm going to take a short break, grab some drink, and then we'll come back. And we'll see whether this actually is looking like the right thing. I think it actually is. And if it is, all is good. Also, we get this disassembly coming out as well, which is quite cute. So we actually get to see the code here. Sharky is how it should be pronounced, apparently. Right, yeah, which shows where the instruction that actually failed at the time of the failure, which is useful. Okay, so I'm going to go for the break. So I'm going to press my new back soon titles, and hopefully this will look all right. See you in a bit. Hello, peoplings. I'm back. Sadly, not reviewing on Pineapple Juice, although I have got it downstairs. I've got tea because I need a little bit of caffeine. Oh, we lost a bunch of people in that break. That's why you should never take breaks. People always leave you. Anyway, so what were we doing? We were, oh, sorry, very quickly. Again, the little intro titles that I was just using, interstitle titles, whatever they're called, were done by Dave Thomas. So thank you very much again, Dave. I'm actually using the pre-release versions for the back soon part, but I'm going to try and tidy up what exactly I'm going to use for these because they're cool. I like this. Right. Excuse me. Where was I? Yes, we were trying to work out what this was and whether it was actually sensible. So what we got there was a DFSR of 606 and a DFAR of 800,000, whatever it was, which was, I think, right. What I shall do though is if we go and start it up with the standard Pyromaniac debugger, we can do the same thing and ShowRegs and see, yep, value 6 and DFAR 88,000. So that looks good. They look like the same sort of thing appeared. PSR slightly different. 6, 10. Interesting. Oh, it's not being printed out here. Possibly because it's exactly the same as the PSR up there. Again, that can be something we can tweak later. Obviously, the values here, we actually put locations in to say where things are. We decode the locations in the different dynamic areas and things. That could be done anyway. It's just a case of implementing it, and for now it's not a big deal. I don't think it's a big deal. Somebody can have a look at it if they wish to. Right, so having got that, the other one we can try and do actually is do call. So we'll just start again, clean system. Call MAT like that, and do ShowRegs. We'll get a different set of answers, and this time it's put it into the IFSR, and of course it's showing us no disassembly as well. If we now load the module, load IM64.debugger. Oh, sorry, 32. And do ShowRegs. Oh yeah, we actually have to cause the failure again. Is that the same? 6? Yes, and there I have. That's exactly the same, which is cool. So now it's just getting this not implemented IFSR DFSR printout working, which is just decoding a bit table. So we can do that easily, he says. So, in order to do that, the easiest way of doing that is to steal the code from Pyromaniac, since we can. It'll be implemented slightly differently, but we can still steal it, almost certainly. There it is. So this is in ShowRegs. I need to know the... Oh, no, that's not, yeah, that's not it. It's the ARM exceptions code. Did I actually close the file? I think I closed it. Yeah, it doesn't matter. Got back over here. That one. Yes, I didn't close it. It was just somewhere else in the list. It's called not describe region, PSR name. Where's the DFSR description, which is in the fault status register. The FSR, I'm assuming that's a object. Dun, 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 dun. Ah, FSR is probably a class inside ARM exceptions, which I just closed. Right, here we are, yes. And there's a nice table of them, because of course there is. Oh, yeah, lovely. And here's the described function, and yeah. So we just read the different types here. Okay, so this is not terrible. I think we can do this. We can transform this code. Maybe not easily, but we can definitely do it. So let's pick all this up and then drop ourselves into here. Now it looks like there's going to be a common section that decodes things, and there's going to be a uncommon part of it, some that's specific to the DFSR and some that's specific to the IFSR. So if I remember rightly, go back to here, constants are in system control. Constant, constant, I'm in the wrong, I have to do it from here, don't I? RISC OS, constant, no, I'm a maniac, constants, system control. I think the easiest thing to do is just dump this all into a header. New file, system control. Give it the same name, it'll be easier for me to find in the future. System control. Definitions of the bits in the system control. I'm only documenting a few of the system control registers here, but this is good enough. Oh, Justin? No, July. It's July 2025. If no def system control. Only applies to ARC 34. Too used to typing the ARC 64 now. Replace all instances of space hash with space // So then we can just do these ones here. La la la. That's good enough. Oops, just align some of these as well. Add all of these as well. Yeah, that's good enough, isn't it? Nicely done. And this one as well. Should be fine. Oops. Put them up here, I think. There, I think that's good enough. It's good enough for now. Alrighty, so we've got that in there. Ah, dear me. Right, so now we need to go and identify each of these into the particular instances. Not that one. Not that one. Not that one. Here we are. So this one's quite simple because we can do, this is the common decoding. So FSR common. Oh, a static function, void, so FSR, int 32t, switch, FSR. This is how you write C, isn't it? I'm not like confused and writing a completely different language. Case, and then turn, tab, write, quote, jump to the end, break. It's all lined up really well. I'm quite pleased with that. Okay, that's the end of the switch statement. That's the end of the function. Now, DFSR to start. So that's this one. That needs to go into here. Right, so if DFSR bracket write not read, oh hang on, I can probably parts.append bracket quote, right. There we are. Oh, I miss semicolons again because, yes, again, I'm forgetting. This is the whole fault status things. Ah, and so we write out a fault status with a particular hex value on it. So what we could do there is we can go default. Right. How was it written? This one. Like that. Did I just... Right. X8. SR. Yeah, so this bit is FSR common, right, common, there we go, based on just those bits, and that will do that. And then this final bit here is just another simple translation again. Oh, except these are meant to have commas between them, because it was appending them into an array and then putting commas between. Oh, well, that's just irritating, isn't it? But whilst it may be slightly irritating, we know that one of those must be set, so it's going to be comma space there. And then these are always going to be preceded by comma space, comma space. There we go. It's now completely correct. That's a little tacky, but it seems to have done the job. Right, and now the same is true, almost, for IFSR as well. So instead, IFSR doesn't have a read not write, so fair enough. That means that this is going to be the first thing, and that's not IFSR, it's IFSR fault status. And this one, IFSR CM, oh no, so these don't exist. The only one is the external abort. Oh, well, I'll just copy and paste. Oh, in fact, that's already defined, so I can just do that, like that. Well, that wasn't too terrible at all, actually. All of those have got semicolons on. Right description has got semicolons on. And this one's got semicolons on. Right, let's do a build. Let's see what happens there, shall we? Oh, back to the actual window I need to use. Build it. Yeah, you need to include your header if you're going to like use the things from it. Oh, that's irritating, isn't it? There's no way of defining binary values. Hang on. Aren't these binary values declared in one of these files? Prep for 001 in HStyle. There we go, DARM internal. I can just cheat. Well, not cheat, I can reuse parts of the system that I've already used here. It's not particularly wonderful, but at least it's a good way of doing it. So, not important. Include internal for the binary. Right, and they're going to be different anyway, so if we're looking here, it's literally just B followed by the numbers. He doesn't have the zeros on the front of them. Oh, maybe I just have to define them myself. Maybe I'll do that. Shall I do that? Yeah, it's only this lot to here. Go. And then all I need to do is take the zeros off these and they will be valid symbols. There we are. I forgot to include IO and system control. 1, 2, 4. Just right, I need to include IO is what I said. And 1, 2, 4. Oh, I've still got system control dot in everything, so I just need to remove that. There we go. Illegal character hex code FF in source. Eh? H, line 1. What? Oh, did I? I think it didn't save. Yeah, I don't know what's wrong with that. I'm going to save the file again. I'm confused. I'm wondering if we've just run out of disk space and that's its odd way of telling me in the Docker environment. No. So what do we think that means? Because it's very odd, isn't it? But it's going to be an error in the file H. Looking fault info. Oh, H. Oh, that's interesting. Okay, fine. I'm not going to worry about that. What was that previously? I clearly must have. Oh, system control. Oh, system control.h. I'm making some really embarrassing mistakes here. Inventing right hex 8. Isn't that in? Oh no, it's the 8 is it's 4. Yes, it was. Dave suggested it was including a directory, so it was opening the directory and going, yeah, I can read that, and then finding no, this isn't a directory at all. It should have probably been faulted in the compiler to say you shouldn't be reading this file. This as a file. Right 8 needs to be right 4 there. Uh, 24. Oh. Yeah. Inventing DFSR probably means I've just duplicated. Yeah, that was meant to be IFSR in there. And I did it again and didn't notice. Oh, dear me. Okay. Let's try this. So, first test is to read memory that doesn't exist. Read memory that doesn't exist. ShowRegs. This is, I've forgotten to load the module, so this is standard Pyromaniac. Says this. Load rm32.debugger. Read MMU access second level. Woohoo! That's quite cute, isn't it? And presumably, if we do it the other way around, so writing, I mean, obviously the error message also tells us this as well, but we're writing it and then we do ShowRegs. Write MMU access second level. Excellent. Obviously it's got slightly wrong with the address there. That's a pyromaniac problem with the instruction pointer not being quite the same, but not a big deal. And then the other bit was calling something that doesn't exist. And you can see that the DFSR and IFSR have been printed because it doesn't know which one you're referring to now, what the actual problem was last time. But both of them are decoded. That's pretty neat. All right, so I haven't committed anything for a while, and yeah, I've got some files that need to be added. So add c/faultinfo, h/faultinfo, h/system, and s/ifsr DFSR. We should also check just before I do that that the 64-bit hasn't become broken. It has not. This is good. Okay, let's commit that. I'll just check what we've actually got in here. So this is, yeah, we've got IFSR and DFSR implemented. Okay, added implementation of IFSR/DFSR printing in ShowRegs. Install ShowRegs if in ARC32 coded using the table on the online. All right, let's push that. Now, I have got a message on my phone telling me your last build's failed, which is slightly embarrassing. So in theory, I've done this, so I should be able to go and move it across. I shall temporarily just move it to in progress. And what I'll do is, how do I get back to DOM from here? I'll go via this, open the tab, go to actions, and we'll see we broke things, and I didn't notice. So what went wrong here? Ooh, lots went wrong. No, these are just warnings. That's disappointing. What was failing at the end then? Don't know how to build lib dollar. Yeah. That's because it's linking to the wrong thing. I've changed. I made a very small change to how things were. So lib$dir is now part of the library of things that you've been given, so other third-party things, and exports is things that you've produced. The idea is that lib is the static part of things, and then exports is the things that you're supplying, and which can override the library. That's the idea anyway, and the path will allow that to happen. But because I've changed the way that it's working, I've not changed the make file. So I just need to make a small tweak to this in lib, I guess. So I should be using xlib for everything. Huh. We are. Oh, that's not fair. Come on. That should have. Let's put it into exports. Don't know how to build. Oh, this looks like my build environment's broken, which is somewhat irritating. Because it was working before, and now it's not. And almost certainly that means I've got to go and redeploy the build server, which is irritating. I guess I need some tests to make sure that works after deploying it. Who'd have thought? But it's working here, isn't it? So if I do it here and do RISC OS ammo makefile lib, comma fe1 export, that's working. And it copies it to exports lib darn. That's probably because I fixed it in this environment but not in the build environment, because I did them slightly out sync one another. I wonder how I fixed that. I have an idea how to fix that. Where's the row build file? Set. Yeah. Export limited. Okay. Export $dir to be lib$dir dot. Wow, that's tacky. No. This change will allow us to push that. And see if this builds. Likely of it working, yeah, we'll see. Ooh, this statement may fall through. I'm assuming those normally happen and I just never see them. Oh yeah, because that's the non-RISC OS build to prove that I haven't broken that version. Directory libs.lib not found. Oh, this is not very nice. I think I've just made a mess of it. Because that's definitely going to break. So that didn't work. Okay, I'm going to have to fix the CI independent of this. I'm having a good time the last couple of weeks with having broken parts. Oh, didn't mean to do that. Having broken parts of the build system. But that's not surprising, I guess. Because I'm pretty sure that the code here is all doing the right thing. So what I'll do is I'll undo that. And push that, so we'll just undo that particular commit. Because this is working now. We have that task was completed over here. So we're now down to ARC64 disassembly, debugger plus flags, instruction comments on constant values, and then FPA instructions. None of which am I feeling particularly enthused to do today because all of them are quite involved. So what I'm going to do right now is call it a day, I think. Yeah, I'm going to call it a day there. So what I am going to do is I'm going to do a quick summary of where we're up to, and then I'll call it a day, and I'll fix the build environment, make sure that that's working, and do a release, which is not hard and not really that interesting. So what have we done today? We have had fixes for the 64-bit code, so the 64-bit decoding that had structures that were wrong. We've got some of the issues with how things were, the length of some of the types as well in other places, not just the decoding of the ShowRegs output. We had fixes for updates for the ShowRegs showing IFSR and DFSR. And we also, what's something else we did? Come on, I did something else. No, can't remember. IFSR, DFSR, the ShowRegs problem. I think that's it. Log. Let's have a look. Yes, it's just these two commits. So that's all I've done. Doesn't seem like much, does it? Oh well, that's life. Yeah, so what I will do is I'll try and fix that build problem. And that's just CI, so not relevant to this. What I would like to ask others is if you've got any suggestions for things that should be done in this disassembler. I think FPA probably needs to be done, but the other bits I might do on my own in some spare time. Or if there's anything that you think I should be working on instead, please let me know. Oh, in the meantime, actually, sorry, yes, there is one other thing. We've got a build. We have a new build of the module. So, RISC OS ammo library. Let's make sure it's all built. Build 64 is one. And then build the module. Build module 64-bit. And then build it 32-bit. There we go. Right, and then move RM32. All of these go into the 64-bit status. And then cd into till projects RISC OS 64 status. And as I mentioned before, this is the status of the 64-bit modules that we've got, and as you can see, there is a new update to the debugger. So I will go and commit those. There's also a version of Perl that's pending there to be added. Updated debugger with working 64-bit module. Oops, module? Dear me. Now works for disassembly, and the 32-bit one, and the 32-bit version has /ShowRegs showing the done, push, and open. And there we are. We now have a updated version with the debugger in there. So, of course, you can download those 32-bit versions and run them and see how badly they work. They should be okay, but some of them are incomplete. All right. Yes, I'm done now. So I'm going to call that a day. Thank you very much for watching. As I say, if anybody got any suggestions for things, feel free to post on the Rule forums, and I will hopefully have a look at that. I mean, I'm trying to post also on the 64-bit forum as well to say, look, this is what I'm doing for the 64-bit side of things. So if anybody's got comments on that, please comment as well. All right. Thank you very much, and see you probably next week. All right. Bye.